reactions of aldehydes and ketones. We'll look at 4 categories of reactions of aldehydes and ketones. These 2 substances are pretty similar in their chemistry, but we'll see some differences. The first is oxidation. Here's the structure of an aldehyde. It's got that C double bond O with the hydrogen attached to the carbon. Then the O in parentheses indicates oxidation. And the O, in essence, inserts itself between this carbon-hydrogen bond. And over here on the right-hand side, we get a carboxylic acid as the product. New functional group, C double bond O with an OH attached. And down here, I've given a specific example. Here's a 3-carbon aldehyde. The aldehyde group is always on the end. When it's oxidized, we're going to get a carboxylic acid. One of the things that you could do maybe to help you understand these reactions would be to have a reaction page where they're all on the same page so that you can compare them and keep them in one place. You'd also want to consider taking that sheet with you to the exam, because when you have an exam question that deals with a reaction, the first thing you can do is look for the functional group, then the reagent that's involved, and that'll help you predict the product. Let's look at a ketone. Ketones have the C double bond O, but instead of having the hydrogen of the aldehyde, they've got a carbon to the left and right. And because they lack that hydrogen where the oxygen typically inserts itself, ketones resist oxidation. So we'll put no reaction over there on the right-hand side. Just the opposite of oxidation would be reduction with hydrogen. And I might mention at this point that all of the reactions that we talk about in organic chemistry are sort of a prelude to the reactions that occur in living systems. They're a foundation for the reactions and processes we'll talk about in biochemistry. In reduction with hydrogen, here's the structure of an aldehyde. We've got that C double bond O. It's pretty reactive. It's like a C double bond C in a sense. And when we can react it with hydrogen, requires the presence of a catalyst that we'd put over the arrow. And what's going to happen is that one side of the double bond picks up one of the hydrogens, the oxygen picks up the other hydrogen. And so we have a structure like this as the product. The double bond has disappeared. We have an alcohol group. And we'd condense this structure a little bit and simply write it as the 2-carbon alcohol. Ketones undergo a similar reaction. Let's look at that. Ketones with the C double bond O can react with hydrogen, nickel catalyst, and again the double bond is going to disappear. The carbon will pick up one of the hydrogens, the oxygen the other, and so the structure that we have over there is an alcohol. I like to remember reactions in words. I think your mind, at least my mind, works in words rather than structures. And in words, a ketone plus hydrogen gives me an alcohol. The next category of reactions are reaction with alcohols. And this maybe is the most complex reaction that we've looked at so far. Let's see if we can make some sense of it. An aldehyde, remember the C double bond O is the reactive portion. It's so reactive, as a matter of fact, that it can react with alcohols. And the alcohol is going to add across this C double bond O. The oxygen will pick up the hydrogen from the alcohol, and the OCH3 will attach to the carbon. It's a reversible reaction. It requires the presence of an acid catalyst, and the product that we get is the structure right here. I've drawn it in sort of an expanded form, and you can see that we now have a carbon that was originally the C double bond O, but it's got an OH and an OCH3 attached. That's called a hemiacetal. And I remember hemiacetal in 2 ways. I remember that hemi means an OH, and acetal begins with A, And that reminds me that this carbon has a hydrogen because it was originally an aldehyde. Hemiacetals are reactive, and they can react with a second molecule of alcohol. Let's look at that reaction. We've got about 8 reactions that we're looking at, and I think one of the ways that you can help keep them all straight is contact time. It's a little bit like hitting tennis balls. It's contact time that really helps. And again, I like to remember them in words. Here we've got a hemiacetal going to react it with a second molecule of alcohol, a reversible process requiring H+ as a catalyst. And what happens this time is that the OH disappears. It combines with the hydrogen of the alcohol to form water as the second product, and the OCH3 takes the place of the OH. So we get a product over here. It's a new functional group for us. We've got a carbon with a hydrogen because it was originally an aldehyde, and now it's got 2 OR groups on it. That's called an acetal. And again, the A reminds me that the original starting material was an aldehyde. Well, ketones can do this exact same thing. We've got a ketone plus an alcohol to give us a hemi product. This time we call it a hemiketal. The K reminding us that the ketone was a starting material, an OH with an OR. And then if we react a second molecule of alcohol with that hemiketal, we get a product where the carbon now has 2 OR groups attached to it. That's the ketal. So again, put all the reactions on one page, and again, look at them several times, and they'll start to make some sense to you. Let's look at the final category of reactions.